Alright, so if we're asked to graph a radical function, we first want to find our vertex. Now, what we need to do is we need to look inside the radical and just outside the radical if anything's added or subtracted at the end. Basically, we're using transformations. Well, this one doesn't go left or right at all, so for my vertex, my x-coordinate is 0, and then I'm going to move down 3, so my y-coordinate is -3. So I'm right here. Okay, so there's my vertex. It's my starting point. Now I want to find a few more values so I can get some points to plot this bad boy and connect some dots. Alright, so the graphs in our class are generally going to go over to the right. Well, pretty much all of them in our class are going to go to the right, but that doesn't mean that graphs can't go to the left or down or whatever. But the ones that we deal with, they're going to go to the right. So we're going to pick some points to the right. Now, strategically speaking, we can pick points that will give us nice numbers, and those would be perfect squares. Now, since it's just x inside here, my next perfect square besides 0 would be 1. So if I plug 1 in for x, the square root of 1 is 1, and then -3 would give me -2. So I was just plugging that 1 in to my x right here. Then, so let's see, I can plot that, 1, -2, boom, right there. Then I need to pick another one. Well, if I pick 2, square root of 2 is a decimal, square root of 3 is a decimal as well, but wait, 4, if I pick 4, square root of 4 is 2, 2 minus 3 is -1. So then I have 4, -1. There's my next point. I can continue on. My next perfect square would be 9. Square root of 9 is 3. 3 minus 3 is 0. So now I'm looking at all the way over, I think here would be 9, 0. So when I connect these, don't forget that arrow, it's going to look something like that. That actually turned out pretty decent for being on an iPad. All right. So strategically speaking, I wouldn't just pick necessarily 1, 2, 3. I can pick out numbers that I know are going to give me nice whole numbers.